Hello everyone, am I audible? So very good morning. Welcome to day 4 of IoT STTP program organizing by Department of EC, Narasaraopet Engineering College. So I warmly welcome you all to the morning session of 1 week National Level Online STTP on IoT and Smart Cities. Hope I am audible and my screen is visible too. And the topic here is smart parking. So today in the morning session I would like to talk about how to create a smart parking infrastructure in related with smart cities, and also I would like to show some demos on it. So if you have any questions related to the previous sessions, you can ping me on my number which is scrolling down to this YouTube live 7893015625. So I'll be assisting you in all possible ways, or else you can mail me on the mail ID mad@madblocks.tech, which is scrolling down. You can find my email ID also. So you can push any kind of request on my mail ID, so I'll be assisting you in all possible ways. So yesterday we have discussed about smart waste management, where I have shown you how to implement MQTT protocol on Google Colab, isn't it? So from Raspberry Pi we have pushed the data onto the Google Colab, where in Raspberry Pi we have created a publisher, and on Google Colab we have created a subscriber. And today the hands-on will be continuity, will have a continuity from the previous topic. So here also we will be using publisher and subscriber, but here in MQTT protocol, yesterday I said that the data which is communicated through MQTT protocol will never be stored in MQTT broker. So they just pass the data to the subscribers, so they don't store any data. But here in smart parking we have to understand that how to store data, because storing data is very important. So if the car is parked in a smart parking space, then obviously we have to store some certain details, right? So we have to understand how to store the data in the IoT cloud. So today I'll be talking about an IoT cloud called IoT ThinkSpeak. So IoT ThinkSpeak is a product of madBlocks. So hope you are aware of MATLAB. So for MATLAB we have an IoT cloud called IoT ThinkSpeak cloud. So I'll be talking about IoT ThinkSpeak cloud for a while, and then I'll be doing hands-on it. So I'll be showing you how to upload a sensory data from Raspberry Pi to the IoT cloud, and also I'll be showing you how to download the data from IoT cloud onto the Raspberry Pi. So this will be my hands-on, and also I'll be talking about how to create a smart parking scenario as well. So in this short session, so let us jump into that. So my name is Madhu Parvatneni. I'll be your instructor in this session. So I'll be quickly talking about what is IoT cloud, and then we'll be talking about some cloud operations. So how to upload the data, how to download the data, because uploading data, downloading data is very important in IoT cloud, right? So if you want to store your sensory data, so yesterday we have used MQTT protocol to communicate the sensory data, but we are not storing the data there. But today I just wanted to show you in the morning part how to store the sensory data in the IoT ThinkSpeak cloud. because in the afternoon we have one more session, like how to have a third party cloud. In the morning we will be using IoT ThinkSpeak cloud, afternoon we'll be using AWS IoT cloud. So let us jump into the technical part which is related to IoT cloud. So let us talk about what is cloud. So cloud is nothing but a place where anyone can access it from anywhere at any point of time. So when you have internet connectivity, you can access, for example, say when you look at Google Drive. So when you look at Google Drive, you can access the files from anywhere at any point of time if your file is stored in the Google Drive, right? So in the similar way, when you store your sensory data in the cloud. So what is cloud? Cloud is nothing but a computer infrastructure. Cloud is nothing but an infrastructure where it can hold the data. So cloud is nothing but a place where you can run servers. So in the afternoon I will be showing how to deploy a server and all, but in the morning session I will be using a service called ThinkSpeak, so which is a product of MathWorks Foundation. So we will be using this ThinkSpeak where the data can be stored very easily. So we will be not talking about any API, so we will directly store the data using some request. So I will be showing you how to store your data using that request, but according to me, as of now, the IoT cloud should have a capability of storing data. IoT cloud should have a capability of visualizing the data. IoT cloud should have a capability of analyzing the data, because according to me, IoT is just a 4D technology. So data collection should be there, data storage should be there, data visualization should be there, data analysis should be there. So when you collect data, when you store data, when you visualize your data, when you analyze your data, then obviously you can create some intelligence there. So analysis anyways will be doing through machine learning mechanisms, or you will be doing through simple rule set, simple by using rules engine also we can create some analysis around it. And when you look into the visualization, you will be using some graphs, and also will be using some visualization charts and plugins in order to visualize your sensory data on the cloud. And when you look at storage, we can use databases. So in the cloud, so we can create a database in the cloud, and you can store your sensory data in the database there. And when you talk about data collection, so Raspberry Pis or the computers or the microcomputers or the microcontrollers will be collecting the data from sensors, and that data will be sent to the IoT gateway. And the IoT gateway, so here IoT gateway is nothing but Raspberry Pi. So Raspberry Pi is collecting the data and it is posting the data to cloud. So cloud is nothing but a place where you can access from anywhere at any point of time. So as of now, so cloud can be different, where can be can be classified into two categories according to me. One is called IT cloud, second one is called IoT cloud. So IT cloud, when you look at IT cloud, it is nothing but you can run any kind of service. So when you look at AWS, or when you look at the Microsoft Azure, so you can have any kind of services that you will have hundreds of services in the cloud service provider, right? But according to me, IoT cloud, so what is IoT cloud? IoT cloud should hold sensory data, IoT cloud should visualize the sensory data, IoT cloud should do analysis on the sensory data. So according to me, IoT cloud is nothing but a service which is related to IoT. So a computer which does all these actions, which can store the data, which can visualize the data, and which can analyze the data. So when you have a service on these three aspects, then obviously that cloud can be called as an IoT cloud here. So today I am using ThinkSpeak IoT cloud. So let me jump into the presentation part. So ThinkSpeak is nothing but an IoT cloud from MathWorks Foundation, where you can store your data, as I said, where you can visualize your data, and where you can analyze your data. So it is free up to 5 channels. If you have MATLAB license, you can easily acquire the license of ThinkSpeak also. But if you don't have any license, it is free up to 5 channels, where you can create 5 channels on ThinkSpeak, and where you can store your sensory data. Okay, so when you look at this, so you will have some different types of services on IoT cloud like ThinkSpeak. You will have React, so which is nothing but analyzing the data. So analyzing the data on the ThinkSpeak cloud. So you can send that data to MATLAB analysis. Once the MATLAB analysis is done, you can send it data to ThinkHTTP. So ThinkHTTP will be calling to various, it is used to send notifications to various people, or it can send notifications to other devices also. So you have ThinkHTTP, and also you have TalkBack, and also ThinkTweet. So these are the different types of services available in the ThinkSpeak cloud in terms of pushing notifications and also you will have MATLAB analysis. As it is a product of MathWorks Foundation, you will have integration of MATLAB. So in MATLAB you will have different types of toolkits, right? So you can use the toolkit in order to analyze the data coming to the IoT cloud. So today I just wanted to show you how to upload the data to ThinkSpeak cloud, and also how to download the data, and also how to do some visualization part on it, and also I will show you how to run a MATLAB script. So I'll show you an example how to run a MATLAB script on the ThinkSpeak IoT cloud. So if you are having MATLAB scripts for doing analysis or for doing visualization, you can easily run it on the ThinkSpeak IoT cloud, as it is a product of MathWorks Foundation here. And if you want to have an account in ThinkSpeak, you can log into this website https://thinkspeak.com. So you can open it and you can create an account in thinkspeak.com, and you can able to access the ThinkSpeak IoT services there. But before you get into the website, you need to understand some dictionary, which is nothing but so there will be some terminologies like channel, field, API and React. So when you look at channel is nothing but a project where you can store your sensory data. Field is nothing but sensory feed, so every sensory feed is called field here in ThinkSpeak IoT cloud. API, so you need an API to interact with the Raspberry Pi or to interact with Arduino, so you need an API. So there will be an API in ThinkSpeak IoT cloud. React is all about analyzing the data, so you can analyze the data based on the React which is available in ThinkSpeak IoT cloud. So these are the different types of terminologies here. So according to me, IoT cloud should do these three actions, right? So it has to store data, it has to visualize the data, and it has to analyze the data. So when your cloud is doing these three services, then you can call it as an IoT service. So this type of three services will be available on AWS IoT Core, so from AWS, and also you'll have Azure IoT service from Azure, Microsoft Azure. So you'll have different types of services from different vendors. So today in this STTP program, so I'll be using ThinkSpeak IoT cloud and also AWS IoT Core, so to demonstrate various use cases on us. So let me jump into the ThinkSpeak IoT cloud. So let me open the website. So you need to open a website. If you want to create an account, you can create it, www.thinkspeak.com. so that is the website, thinkspeak.com. so let me open the magnifier also to magnify my screen. So you need to log into thinkspeak.com. So this is a website, thinkspeak.com. So when you open this website, you can able to see the data which is related to IoT cloud. So you can see ThinkSpeak for IoT projects. So you can able to see different types of projects for students and educators, and also you can able to see different types of projects related to it. So ThinkSpeak for energy monitoring and ThinkSpeak for smart farming and all. So you can able to see some different types of projects also. So I guess at educator point of view, so you can easily access ThinkSpeak, and also you can integrate with MATLAB. So if you can have MATLAB license with colleges and all, right? So you can easily access this ThinkSpeak and do a lot of projects so related to IoT and related to analysis also. So it's all about collecting the data from different types of sensors and storing the data in the cloud and doing some analysis. So when you do analysis, you will be getting some predictions, right? So you can easily use act policies which are available on ThinkSpeak, where you can easily trigger an action here. So it's all about three things, right? One is collect, so collecting the data from sensors. Analyze, so once the data is collected, data will be stored in the database of ThinkSpeak, and once the data is stored, you can easily analyze or visualize the data using some MATLAB scripts. And also you can easily, once the analysis is done, you can easily predict, right? So then you can send notifications, so which is nothing but act. So act is nothing but trigger a reaction. So trigger a reaction is nothing but sending a notification or switching the other devices. say if the moisture content, say if the if the dustbin is full, so you can send a notification, right? So those kind of things is also can be done on ThinkSpeak IoT Cloud. Or or if the vehicle is parked at so and so slot, then immediately you can also send a notification saying that how many slots are available. And also you can able to send any kind of notification by using act policies which are available here. And also you can easily integrate with various apps. So you can easily integrate with Android app, or you can easily integrate with iOS app. So they will be providing some APIs in order to integrate. And also you will be having MQTT APIs and also RESTful APIs. So this is the most important topic, that what you have to understand is that if you want to upload the data, so you need an API, right? Without API we cannot able to upload the data. So by using in MATLAB, you can easily upload by using REST API or MQTT API. So when you look into the MQTT API, you need to publish to a channel. So channel is nothing but a project. So if you want to publish to a channel feed, then you have to select this API, publish to channel feed. So they will be showing you how to publish the data. So the channel ID and API key has to be sent as an as the data to publish your sensory data here. So you can use either HTTP, or you can use either MQTT for publishing the data. Okay, so this is how you need to publish the data. So field 1 equal to 45 and field 2 equal to 60. So which means that you are uploading two sensors here, 45 and 60, and status equal to MQTT publish. Okay, so you can use MQTT protocol, or you can use HTTP protocol in order to publish the data. So you can use even WebSockets also. You can use WebSockets also in order to send data onto the ThinkSpeak IoT Cloud. Okay, so let me jump back to the account. Okay, so let me jump back to the account. So what you have to do is, if you don't have any account, so you can click on this profile icon. So when you click on this profile icon, it will be asking to log in. If you don't have any MathWorks account, so as I said, ThinkSpeak is a product of MathWorks, so it will be taking the login of MathWorks only. So if you have MathWorks account, you can easily enter your email ID here, and you can sign in. So when you click on next, so it will ask you to enter the password. So when you enter the password, you can log in into ThinkSpeak IoT Cloud. So if you don't have any account of MathWorks, then you can click on create one. So when you click on create one, it will ask you to enter your name, email ID, password, and confirm password. So you will be getting a verification link to your email. So when you click on that verification link, you can activate your ThinkSpeak IoT account. Okay, as of now I'm having an account. So if you want to do hands-on with me, so make sure that you have MathWorks account. So it will take only 2-3 minutes in order to create an account, right? So my account, I'm having account of MathWorks, so let me enter my details here. If you don't have it, you can create it, so there is no issue there. So let me click on next. So it is asking to enter password. So I have entered my password, and let me click on sign in. Or else you can create an account and ThinkSpeak IoT Cloud. So the account is like, it will be taking the MathWorks account. I guess most of the electrical and electronic faculties will be having the account in MathWorks, right? Because in the academic purposes people use MATLAB. So when you use MATLAB, you will be having MathWorks account, so you can easily log in with MathWorks account onto the ThinkSpeak IoT Cloud. So if you don't have it, you can create it. It will take only 2-3 minutes. Okay, so are you all following me? Okay, 1 2 3 4. Okay, let me delete one device. Okay, if you want to delete, then you can go for channel settings. I mean, it will allow only 5 devices. Okay, Okay, let's look at data import or export. There will be some option here. So in the channel settings only you will be having delete channel. So I'm deleting one channel because it is allowing only 5 channels. Okay. So when you create your account for the first time, you will have an empty channels, right? So for me it is showing 3 channels. So which are the previous channels which are getting created in the previous demos and all. So here my account is logged in. So you can able to see that here my account is logged in. So I'm using the the ThinkSpeak from very long time, okay, right from 2015 2013. So I'm using ThinkSpeak IoT Cloud for various demonstrations here and there. Are you all ready? Can we start? So here I have logged in into ThinkSpeak with the MathWorks account, and then what I have to do is I wanted to store the sensory data. If you wanted to store the sensory data, you have to create a channel. So after creating the channel, then only you can store the sensory data in ThinkSpeak IoT Cloud. So a channel is nothing but a project. So you have to create a project or you have to create a channel. So in order to store the sensory data. So when you are creating this channel, it will be asking how many sensors are there with you to upload the data. For example, say in some cases people will be having 3 sensors to upload the data. Sometimes people will be having 4 different sensors to upload the data. So it all based on the project and the application context, right? So we cannot say only one sensor will be there. So we can have one sensor, we can have 2 sensors, or we can have 3 sensors, we can have n number of sensors based on the application context. So that is what, while creating a channel, so you have to select how many sensors do you have. So do you want to upload the data into the ThinkSpeak Cloud? So let me click on new channel. So when I click on new channel, it is asking me to enter some name. Okay, let Smart City IoT NEC STTP Smart City. So description, you can write anything or you can leave it empty. So nothing is fine. So I'll let demo. So you can able to see, so every channel you have to enter some name and description, and field 1, field 2, field 3, field 4, so on, field 8. So there are 8 fields here. So field is nothing but sensor. So you can upload maximum of 8 sensors to one channel. Say if your project is having 5 sensors, you can create one channel and you can upload the data. If your project is having 8 sensors, you can create one channel and you can upload the data. If your project is having 14 sensors, then you cannot upload the data into one channel, right? So then what you have to do, you have to create 2 channels, first 8 sensors to one channel and next 6 sensors to the second channel. So one channel is limited to 8 number of sensors. So sensor is nothing but field. Sensor is nothing but field. So you are having field 1 to field 8. Okay. So here let me enter some sensor name. Okay. So let me enter some sensor name. So let me enter ultrasonic sensor. Okay. Ultrasonic sensor. So if you have one more sensor, you have to enable the checkbox, then only you can able to enter the sensor name. If the checkbox is enabled, it means that you are having that sensor. Okay. So when you enable the check, say here how many checkboxes are enabled? There are 2 checkboxes enabled. So which indirectly means that you are interested to upload 2 sensors data. So when you enable the third checkbox, it means that you are having 3 sensors to upload the data. So when you enable the next checkbox, you are having 4 sensors to upload the data. Okay. So let me disable it. As of now, I am having only 1. Okay. So like this, you have to enable the checkbox, and then when you enable it, so it indirectly means that you are having those many number of sensors to upload the data. Getting my point? So here we have to enable only one checkbox because I am having only one sensor connected with Raspberry Pi. So yesterday we have connected this sensor, right? So today I can use the same sensor for understanding whether the car is parked or not. So if you want to link your project site, so you can enter that website here, which is project site. Or if you want to link your GitHub profile, the project code profile, you can link that GitHub profile here. So elevation, that is not required, elevation in the sense the latitude and longitude. So it will ask us to enter the latitude and longitude where the project is deployed. So generally when you look at IoT, so it will be deployed in a remote area, right? So when it is deployed in a remote area, generally it will be asking us to enter the latitude and longitude. So these details are not mandatory. So if you want to enter, you can enter it. Okay. If there is any YouTube video of the project, you can enter those details also. So as of now, nothing is required. So we have to click on save channel. So when you click on save channel, immediately this channel will be created with the number of checkboxes, right? So with the number of sensors here. So we have only one checkbox enabled. So which means that you have only one sensor with us to upload the data. So let me click on save channel. So when I click on save channel, so immediately channel will be created. You can able to see the channel is created now. So when you see this channel status, obviously it means that a channel is created. So you can able to see some charts here. So what is this chart? Chart is nothing but a visualization of data. So as of now it is nothing visualized, right? Because we have not uploaded any data here. So on the x-axis you can able to see date. On the y-axis you can able to see ultrasonic sensor. So that is a name which is given at field 1. So this is like field 1 chart. If you enable 2 checkboxes, you will get one more chart here. Okay, so the number of charts will get increased based on the based on the number of fields you enabled in the channel creation. So if you enable 3 sensors, you can able to see 3 charts here. If you enable 4 sensors, you can able to see 4 charts here. But as of now, I have enabled only one field, so thereby I can able to see only one field chart. Okay, so every channel you create will have a unique channel ID. So you will be having unique channel ID. So channel ID will be different from channel to channel. It will be unique from account to account, channel to channel, and other obviously the username which is assigned with your account. So it is showing as madPIoT. So that is my username. Access is private, so it means only you can access it. So you can change it to public view, or you can change it to you can share with this. You can share this channel with someone else, okay, by using some email IDs and all. I'll show it later. But as of now, it is showing access is private and the description is demo. So that is what we have entered while creating channel, isn't it? So here you will be having 2 buttons here, MATLAB analysis and MATLAB visualization. And you can also visualize the data by using MATLAB scripts and all by clicking on this button, or you can analyze the data based. When you click on MATLAB analysis, it will be jumped to the MATLAB analysis page where you can do analysis on the data which is uploaded. But as of now, the data is not uploaded, right? So as of now, the data is not uploaded. You can able to see the empty chart here. Okay. So let me click on public view. So when I click on public view, if there is any if the channel is public, you can able to see the channel here, but it is not public, right? So to make this channel public, navigate to sharing. So in the sharing, you will have some settings. Okay, so you can make your channel public, or you can make your channel private. So you can have the settings here. Keep channel view private, that is a by default option. If you want to enable with everyone, so you can do this, share channel with everyone. Or if you want to enable the channel view with the following users, so you have to enter their your email IDs of ThinkSpeak, of MathWorks, so they can able to see your channel. You can able to see your channel. So you can put it channel private. This is very simple, right? So which is like sharing some file. So in Google Drive, generally when we upload the files, it will be private by default. So you can share with public, and also you can share with the with your friends and all, right? So the same thing will be there here also. So as of now, your channel is private. And let me click on channel settings. So when I click on channel settings, you will have some details like if you want to add one more sensor, you can add it here. If you want to edit your name, you can edit, but the channel ID will be fixed. Okay, you cannot have the another channel ID here. Channel ID is fixed. So you can, if you want to add sensors, you can add it here. And also if you want to clear the channel, so if you want to clear the channel, you can click on this button. The channel feed, the sensory data which is stored in your channel will be deleted. And also if you want to delete this channel, you can click on this button, so the channel will be deleted. So these two options are very important. Like when you click on this button, the sensory feed which is uploaded to your channel will be cleared. And also when you click on this button, so the channel will be deleted from your account. So these are the quick options which I wanted to show you when you are a beginner in ThinkSpeak IoT Cloud. So and next comes is API keys. So API keys are very important. You will have application programming interface keys. You will have two different keys. One is called write API key. Second one is called read API key. Write API key is used to upload the data, and read API key is used to download the data. So if API key is open, say if everyone knows our API key, we can create a new API key. But API key is like an OTP, right? So you have to save your API keys in a protective place, in a safe places, right? So when they have API key, they can upload the data. So when they have API key, they can download the data. So sometimes when you have write API key, they can upload the malicious data, right? So which is the garbage data. So that is why you have to put your write API key safely, because that is very important. So here, use this key to write data to a channel. If you feel your key has been compromised, click generate new API key. Okay, and also you can generate new read API key here. So you can generate write API key, and also you can generate read API keys here. So API keys are very important. Every channel will have a unique API key. So using the API keys, you will be uploading the data, and also you will be downloading the data. So application programming interface keys. So these keys are very important, and you will have request also, API request. So you are having some request here. So by using this request, we will be uploading the data, and we will be downloading the data. So when you look at the first API request, write a channel feed. So here you have some API request. So if you look at this API request, write a channel feed. Write a channel feed is nothing but uploading the data to the channel. So if you want to upload the data to the channel, then you have to call this write a channel feed. If you want to download the data, then you have to call read a channel feed. So if you want to read a channel feed, a particular sensor, then you can go for this. If you want to read the status updates, you can go for this. So there are the 4 different types of API requests here. So out of which generally first and second are most important, because the first one is writing a channel. So uploading the data is only one API request is available here. Remaining are read, right? So which are nothing but downloading requests. So here it will download the entire channel, it will download the entire sensor. So generally when you have 8 sensors in the IoT ThinkSpeak Cloud in the channel, if you want to get only one sensor data, then you can go for this channel field. So if you want all the sensory data from ThinkSpeak Cloud, then you have to go for this. If you want to get the status update, then you can go for this. So there are 4 different types of API requests here. One it will be talking about how to upload the data, and the remaining 4 it will be talking about how to download the data. So you will have different types of API requests here. Okay, so this is the API requests which are available, and also you can export and import. Okay, so you will have data import or export. So by clicking on data import or export, you can import the data, and also you can export the data. So if you want to import the data through CSV, you can import it. Say if you don't have any sensor connectivity, then by using import option, we can import the CSV file, and you can plot the graph, and also you can do little analysis on the data. So if you want to export all the data from the channel, you can do this. Okay, so export, so it will export all the data which is getting stored on the IoT ThinkSpeak channel. Okay, so any doubts here? So these are the different types of options available. So it will export all the data which is getting stored on the IoT ThinkSpeak channel. Okay. So any doubt so far? Okay, so can I go for next? So let me connect my Raspberry Pi meanwhile. If you have any doubts, you can ask me. So let me connect my Raspberry Pi. So here is my Google Colab. So yesterday also I have shared it, right? So this is a program which we wrote yesterday. Like we are sending data to Google Colab. Google Colab is uploading the data. Is receiving the data from Raspberry Pi. Okay, so my Raspberry Pi is connected, so we can start scripting the program. So I'll tell you what I'm doing here. Okay, so there are two types of implementations which I wanted to demonstrate. The first type of implementation is with IoT gateway, and the second type is without IoT gateway. So I wanted to show you two types of implementation, with IoT gateway and without IoT gateway. So what is with IoT gateway? With IoT gateway is nothing but you will have an IoT gateway, you will have an end device. Okay, so end device, say here Raspberry Pi, IoT gateway, say Google Colab. Okay, so we have an IoT gateway, say Google Colab, end device Raspberry Pi. So here what I wanted to do is Raspberry Pi will upload the data, will send data to IoT gateway. So what is IoT gateway here? Google Colab. So IoT gateway will upload the data, will upload the data to ThinkSpeak. So this is one kind of implementation with IoT gateway. So in sometimes you will have some scenarios like you have to upload the data via IoT gateway. For example, say if you look at the college infrastructure, say sometimes you will be taking say sometimes you will be taking a permission through principal, right? And sometimes through HOD you will be taking some permissions. Okay, so if you want to take permission through principal, that is like the global, right? So that is like global. Irrespective of the department, you can have the access there. So when you take permission through HOD, it is like local. Okay, so you have to talk about which department you are from, and also which HOD has given you the permission to access it and all. Okay, so here also if Raspberry Pi is a standalone device, if Raspberry Pi is standalone device which is like local device. Okay, if a Raspberry Pi standalone device, then you can upload the data directly. Okay, so if the principal is not available in the campus, the HOD will be taking the authority there. Say if Raspberry Pi is a standalone device, then you can upload the data directly. But when you have a network of Raspberry Pis, so when you have a network of Raspberry Pis, so each Raspberry Pi cannot do authorization. Okay, each Raspberry Pi cannot have an access to upload the data directly. Okay, when you have a network of Raspberry Pis, I'm talking about network of Raspberry Pis, then what you have to do, then you have to upload the data through IoT gateway. So this is what you have to do. When you have a single device, then it is fine, you can upload the data directly. But when you have a multiple devices, when you have a network of devices, so all the devices cannot upload the data directly, because we cannot provide internet to all the devices. Say there are 1000 devices. Say when you look at the smart parking, so when you look at the smart parking, you will have multiple number of slots, right? In one space there are 100 slots. Okay, in one space say there are 100 slots. Can you provide internet to all 100 slots? No, right? So we cannot provide internet to all 100 slots. So thereby we have to choose one gateway. So that gateway will be connected with all 100 slots in different networks. So here in smart parking, you will be getting a scenario like, in smart parking you will be having a scenario like you will have 100 slots in one space. Okay, so all 100 slots you cannot provide internet connectivity. So providing internet connectivity to all 100 slots is very complicated. Then what we do, we divide them into networks. Okay, we divide this 100 slots into heterogeneous networks. So what is heterogeneous network? Say 20 slots or 25 slots I will put in Bluetooth network. So they communicate via Bluetooth. So 25 slots I will keep in Zigbee network, and 25 slots I will keep in Wi-Fi network. 25 slots I will keep in RS485. So RS485, I hope you are aware of it, right? So it's a wire network. Okay, so what I am doing here, I am dividing the entire 100 slots into different heterogeneous networks. Okay, so here, so 25 slots are in Bluetooth network, 25 slots are in Zigbee network, 25 slots are in Wi-Fi network, 25 slots are in RS485 network, and you have only one IoT gateway. You will have only one IoT gateway. It is like one college will have only one principal, right? But you will have multiple HODs. So here, according to me, IoT gateway is like a principal. So 25 slots. In 25 slots, you will have a coordinator. So that is like you will have a coordinator of the network who coordinates the network. If you want to add one slot to the network, through this coordinator you will be adding that slot. So every network will have a coordinator. So that coordinator is like head of the department. So every group, every network will have a coordinator. So that coordinator is like head of the department. So you can have multiple head of the departments, but you will have only one college principal, right? So in the similar way, you will have only one IoT gateway. But this IoT gateway is connected to all coordinators. So one principal. So if you want to put a meeting, then the principal will be calling all the head of the departments, right? So all the HODs and principal will sit together and they discuss all the points in the college. So in the similar way, this IoT gateway will be connected with all the coordinators. Say there are 4 networks here, so you will get 4 coordinators, isn't it? So all the 4 coordinators, the IoT gateway will be connected to all 4 coordinators in the network. So say a slot ABC is in Bluetooth network. Say a slot ABC is in Bluetooth network. If this slot wants to communicate, with user, say, then what it will do, slot ABC will send data to coordinator. Then what coordinator will do? Coordinator will send data to IoT gateway. Then what IoT gateway will do? IoT gateway will pass data to cloud. Then what cloud will do? Cloud will pass data to user through mobile app. Okay, slot ABC is in the Bluetooth network, and if you want to communicate, say some theft is happening in the slot ABC car, say someone is thefting, okay, say someone is doing some malicious thing at slot ABC, then how do they get communicated? So slot ABC is sending data to coordinator, and the coordinator will be sending data to IoT gateway. IoT gateway is sending data to cloud, and the cloud will be sending data to user through mobile app, and also local intimations also happen. Say when someone is thefting the in the parking slot, immediately siren will be on. The security which is available at at the smart parking slot, they will be getting a notification on their mobile app saying that something is happening at so and so slot. So a red alarm will be on at the parking slot. So everything will happen, but I'm talking about user perspective, because user will not be available at parking slot, right? So I have parked at smart parking slot, and I'll be sitting in my office cabin where I will get a notification on the mobile phone, okay, because I will not be available at smart parking space, right? So a siren will be on. Though siren is on, I cannot be notified because I will be far away from the smart parking space. Okay, so then what will happen? What is the scenario there? The slot ABC has to communicate with coordinator, okay, and the coordinator will be sending data to IoT gateway, because coordinator doesn't have any internet connectivity. So what coordinator is having? Bluetooth connectivity. So through this Bluetooth connectivity, it will be connected with IoT gateway. And what IoT gateway will do? IoT gateway will have internet connectivity, but it cannot have user data with it, okay. IoT gateway doesn't have any user data. So who is having user data? Only cloud is having user data. On the cloud, people are storing all the user mobile information and all, mobile data, email data. So everything is getting stored in the cloud. Then what will happen? IoT gateway will be sending data to cloud, and the cloud is sending a notification to user through mobile app. So this is the infrastructure, right? So you cannot have a simple notification directly from slot ABC to mobile app. Okay, you cannot have slot ABC directly sending notification to user, but in between them you will have some certain infrastructure needed, because when you look at smart parking, you will have multiple number of slots, right? So here your slot is not a standalone. Say for example, when you look at your home scenario, you will have only one slot. So there is no need of coordinator because you have only one slot, and there is no need of IoT gateway because you have only one slot. So when IoT gateway is needed only when you have multiple number of slots. IoT gateway is needed when you have multiple networks. So here there is no network needed. You have only one slot. So you can send data directly to the cloud, and the user will be notified through the mobile app. Okay, this is home scenario when you have only one slot. So is this fine with my implementation part? So have you understood this? So there is a question like difference between feed and field. Feed and field both are same. So you're talking about, I guess, here, right? Data import, API keys, I guess. Okay, let me zoom it for you and let me explain that. So I hope you're talking about this. Read a channel feed. Read a channel feed in the sense, all the sensors data. So you can get all the sensors data. Say if your channel is having 4 sensors, if you call this API request, it will give data related to 4 sensors. So that is nothing but channel feed. Channel field. So out of the field, how many sensors are there? 4 sensors are there. So if you want to read only one sensor, then you have to call, see here, https:/api.thingspeak.com/channels/ some channel number /fields/1.json. What is the number here? 1.json. So which means that you can read only field 1 data. Okay, which means that you can read only one sensor data. If you put 2.json, you can read second field. If you put 3.json, you can read third field. If you put 4.json, you can read fourth field. So like this, you can have 8 number of JSONs, right? So you can have 8 fields. So you can call 1.json for first field, 2.json for second field, 3.json for fourth field, third field, and so on. Okay, so channel field is, so you will get only one sensor data. Channel feed is nothing but you will get all the sensory data. Okay, when you have 8 sensors, say, so you will get all 8 sensor feeds. Okay, so you can simply say that channel feed is nothing but all sensors data, channel field is nothing but one particular sensor data. So that is how you can differentiate it here. But as far as now, my channel is having only one sensor, right? So my channel is having only one sensor. For me, channel feed and channel field both are same, but because we are having only one sensor. But when you have two sensors or three sensors, when you have more than one sensor, then channel feed and channel field will be different. Okay. So when you read channel feed, so you will get all the sensor data. So when you have channel field, you will get only respect to channel field. Okay. Hope you have understood. Okay. So this kind of infrastructure is needed. Okay. So you can do little research on this. So because people are doing various projects on these scenarios, and they are publishing some IEEE papers and all. So how to create a coordinator, how to put a coordinator, how coordinator will coordinate all the activities. So you can do lot of research activities there. So there is a lot of research scope in this topic. Okay. So IoT gateway and cloud and user and mobile app. Okay. So here, so let me show you the two implementation parts. First implementation is with IoT gateway. So with IoT gateway. So then what I have to do? Raspberry Pi has to send data to Google Colab. Google Colab has to send data to ThinkSpeak IoT Cloud. So without IoT gateway, Raspberry Pi to ThinkSpeak IoT Cloud. Okay, so here it is a standalone device. So you are having only one device. So I just wanted to show you how to do with IoT gateway and how to do without IoT gateway. Okay. So let me jump into the programs. So let me do with IoT gateway first, and then I'll do without IoT gateway. Okay, nothing to confuse. So I'm having two scenarios here. One is with IoT gateway, second one is without IoT gateway. Okay, so here what I do is, for you to understand, I'll be using MQTT protocol here and also HTTP protocol. And here also I use HTTP protocol directly, no need of MQTT protocol. Okay, so let me do the first one. So let me do the first one with IoT gateway. So here with IoT gateway, you will have Google Colab, which is acting as gateway, and you will have Raspberry Pi as an end device. Okay. Say Raspberry Pi and Google Colab are in the network of MQTT. So they are connected over MQTT. Okay. And here we have a sensor called ultrasonic sensor. Okay. So here what should be the flow? The sensor should send data to Raspberry Pi. Raspberry Pi should send data to Google Colab. Google Colab should send data to ThinkSpeak IoT Cloud. Okay, so this is one kind of implementation. I'm not saying that this is the right one, but when you have IoT gateway, you have to bypass through IoT gateway only. Okay, so when you have multiple devices, obviously you have to get IoT gateway into picture. Okay, so that is why I'm showing this implementation here. So here I need two programs. Here. Program 1 is between RPI and Google Colab. This is program 1. Program 2. So I need in between Google Colab and ThinkSpeak IoT Cloud. So I need two programs here. Program 1, RPI and Google Colab. So we need to write a program in such a way that the sensor connected to Raspberry Pi should read, and that data we have to pass to Google Colab. And we have to write program 2. Program 2 is nothing but we have to send data from Google Colab to ThinkSpeak IoT Cloud. Okay, two programs. So here in the program 1, I will be using MQTT protocol. So as yesterday, as it is discussed, and here I will be using HTTP protocol. So in program 2 I will be using HTTP protocol. Okay, so let me write the program 1 first. Program 1 is RPI and Google Colab. I mean sensor, your sensor will be having sensor, RPI and Google Colab through MQTT protocol. So let us do this first. Okay, hope you are following me. So let me open the Raspberry Pi. So I am using VNC viewer. Okay, I am using VNC viewer. So it is there in my taskbar. So I know the IP address of my Raspberry Pi. So yesterday also I have shown you, right? So if you have not joined yesterday video, it will be there in our channel. You can view it. So let me open this. Okay, so IP address is same, 192.168.0.86. So VNC is enabled on my Raspberry Pi. Username is Pi and password is Raspberry. So that is the password. So I have to click on OK. When I click on OK, you can able to see VNC viewer. You can see my Raspberry Pi desktop, which is opened on my laptop. So here we have to open terminal. So this is the terminal icon. You can click on this terminal icon. So you can able to see Pi at the rate of Raspberry Pi. So when you have Pi at the rate of Raspberry Pi, you can able to create some Python scripts whenever it is required. So let me write some programs here. So yesterday also we have written, right? So let me use the same program syntax. So let me jump into that folder. So yesterday I have created some folder, right? So let me type ls. So when I type ls, you can able to see some different types of folders which are already there. So yesterday we have created this folder, right? IoT-smart city. So let me use the same program, same folder, cd space IoT-smart city. Okay, cd space IoT-smart city. So your terminal will enter into this folder. So let me click enter. So you can able to see there. So when I type ls, you can able to see yesterday's file. So yesterday we have written a file called dustbin.py. So you can able to see that. Okay, so here, so let us create a file. Let us create a program. Sudo space nano space slot gateway.py, slot underscore gateway.py, sudo space nano space. So yesterday I have explained it, right? Sudo super user do, you are asking the super user to create this file. Okay, it is indirectly means that you are asking the super user to give some administrative privilege for this command. So nano space, nano is nothing but notepad editor on Linux operating system. Slot underscore gateway is nothing but file name. Extension is .py, so which is nothing but Python script. Enter. So when you hit enter, an empty file will be created. So here we have to type the program. Okay, but yesterday we have typed it, right? So let me use the same program. So because the time is running up, so let me do, yesterday we have written this file, right? So let me use the same program because the same sensor, right? So when you have same sensor, obviously same program comes in place. So we have to change some terminologies. I'll change it. If you want to paste it, you have to copy from the Google Colab, right click on this and paste. So when you paste it, you can able to see your code here. Okay, so let me delete some lines. Okay, let me delete this if condition because if condition is not required as of now. So send to Colab. So hide 01 str distance. Okay, so that if condition is not required. So yesterday I have explained this program. You can see that video also in the YouTube channel. So instead of publishing with dustbin, let me change the topic name. I can write any topic name in MQTT broker. As our broker is open source broker, you can have any topic name. Okay, I'll put parking / hide 01. Okay, so what is my topic name? Parking / hide 01. Okay, let me write on my notes. Okay, I've written So I have explained each and everything in the yesterday's video. Okay, so I just editing this code. Okay, so everything is correct. So Control X. So yesterday I have shown you how to exit from the notepad, right? Nano. So Control plus X. So you need to press Y to save the file, and you have to hit enter. So when you hit enter, you can go back to the terminal. Sudo, and here we can run the program sudo python slot_gateway.py. But before that, let me open my Google Colab. So yesterday we have written some Google Colab program, right? So let me use the same program. So I have explained the syntaxes and all, right? So you can see the yesterday's video. I have explained why I have written every line, so you can use that. Okay, so now here I am pasting the program which is copied above. So here I have to change the topic name because the topic name is parking. Okay, so I have to change the topic name. I am using the same broker as yesterday. Parking, yes. So let me run this file. So if I run this file, so it will be connected with broker and it will be subscribing the data. Okay, so you can able to see circle rotating fastly, so which indirectly means that your program is able to receive data. So there is some mistake, what it is? Okay, no module named PAHO. So if you get this error, module not found error, we have to install some module. So yesterday also I have shown you how to install it, right? So you can install by using the same command. So let me install it. Yes, pip install PAHO-mqdt. So let me click play button again. So when you close this Google Colab instance, then this packages will be removed. Okay, so again we have to install it manually. So now it is installed. Now let me run this program. Yes, it is connected and it is trying to receive the data. So let me run the program of the Raspberry Pi. Sudo space, let me clear the screen for you. Sudo space python space, what is the name? I forgot the file name. Slot gateway. Okay, sudo python space slot gateway.py. So here it will print the distance, right? 175.5 centimeters. So you have to get the same data on the Google Colab also. So on the Google Colab also you are getting the same data. B single quotation $height 01 hyphen the same sensory distance, right? So yesterday also I have shown you the similar output, right? So where I have changed the topic name, that's it. So yesterday to today's program, so what I did here, the topic name was changed, but the implementation part is same. Okay. So we are receiving the data from Raspberry Pi. So the Google Colab is receiving the data from Raspberry Pi. So on the Raspberry Pi you can able to see the same values printing there. So here also it is printing the same value, right? So it is also printing the same values on the Raspberry Pi and also on the Google Colab. You can able to see the same thing, but extra B is coming here, right? So extra, if you see in the starting letter of each line is starting with B. So that is called bytes. So that is called encoded data format. So this is encoded data. So we cannot access the data. So what we have to do is we have to decode this data. Okay, so let me decode that data. So every data is encoded. So the data is looking same, but every line it is starting with B. So that is called encoded data. So that encoded data has to be converted into decoded. Okay, so we have to decode the data because it is encoded there. So let me stop this program and let me decode the data. Okay, so to decode the data, what I have to do is I have to store this data in some variable. Okay, so let's say t equal to msg.payload. So here I have to decode the data. So to decode the data, what I have to do is t equal to t dot decode of. So the data encoded will be in a format called UTF-8. So this is the encoding and decoding format in Python. So this is the encoding and decoding format. Okay, now the data is decoded. So let me print the value of t. So let me print the value of t, you can understand. So let me run the program. So if you run the program, now you should not able to see B, okay, printed there. So you cannot able to see B, right? So directly the string value is getting printed. So previously before decoding, so we have seen something like B single quotation open the value, but here if you see now, there is no B because that is decoded. Now your data is decoded, you can access 177.14 and all, right? So what is your target? Your target is to upload this data. Your target is not to upload all this, okay? Say if your target is to upload this data, or if your target is to upload all the data, so anything is fine, but let me upload the data of this value, okay? So every line I don't want to upload height 01 dollar and all, so I wanted to upload this floating point value, okay? So I wanted to upload the floating point value. Say how to upload that floating point value onto the ThinkSpeak IoT cloud, that is what I wanted to show, okay? So here what I wanted to do is, so every line, from every line there is a floating point value, right? So I have to extract that floating point value. I have to extract that floating point value from this line. So let me put some syntax. So let me stop the program. So let me have some syntax. If you see that, if I want to extract that value, so that value is after hyphen, right? That value is after hyphen. So let me use that syntax. So let me have t equal to t dot split of hyphen print of t. So here there is a method called split in Python. There is a method called split. So now what will happen is this entire line will be splitted into parts. This entire line will be splitted into parts. Okay, where is hyphen here? So in this entire line you have hyphen here, right? So then immediately what will happen is this entire string will be splitted into two parts. In the first part you will have height 01. In the second part you will have 177.14 space centimeters. Okay, so let me run the program. Let me show you that. So I am running the program. You can able to see here now it is splitted. So see, the previous value is splitted into height 01 as one part and 174.53 space centimeters into the second part, because we have splitted by using hyphen, okay? And then what we have to do is, if you see, we have, this is called collection, okay? So in Python the fundamental collection is list data type. So this is called list. So in the list we have at 0th index we have height 01. In first index we have 174.53 centimeters. Okay, then what we have to do is we have to access the this value by using its index. So 0th index is this, always index value starts with 0, right? So 0th index is height 01 and first index is nothing but, so what we have to do is we have to put square bracket 1. So we are accessing the value, through index. Okay, so let me stop the program. Let me play it again. Now you can able to see only value is getting printed there. So now you can able to see value is printed there, 176.8 space centimeters. Okay, so like this we have to split. Okay, so we have to split, we have to identify where to split. Now again this is also you are getting space centimeters. So I wanted to remove this space centimeters also. Then by which character we wanted to split now? So now I have to split by using space. Okay, so I wanted to split again by using space because I need only floating point value. I should not upload this space centimeters. When I upload this space centimeters, I cannot plot the graph, because when you want to plot the graph you need a numeric value, right? So when you have a categorical value like space centimeters, you cannot plot a graph. So that is why what I will do is I will split again. I'll split again, t equal to t dot split of, this time I'll split with the help of space. So space is also a character, right? So I'll hit space in between single quotation. Many times people forget giving space. Space is very important. So I am splitting the string with the help of space. Then what will happen? So here only one space is there, right? So this will be splitted into one part and this will be splitted into second part. So let me stop the program and let me run the program again. So because I have splitted again, now you can able to see the value is splitted. The value is splitted into one part and centimeters is splitted into second part. So again I am having index, right? So in which index the value is getting stored? In 0th index, right? So I have to put square bracket 0. I have to put square bracket 0. So when I put square bracket 0, what is the value I am getting there? You can able to see. Now only floating point value will get printed there. Okay, only floating point value will get printed. So this floating point value I wanted to upload to ThinkSpeak IoT cloud. So thereby I can see the graph. Okay. So here my program 1 is done, like I have received data. The IoT gateway alias Google Colab is receiving data from Raspberry Pi, and we have done some pre-processing before uploading the data directly. So before uploading the data directly, we did a simple pre-processing, where in the pre-processing we want only sample the sensor value. So that is why we did some split and we have accessed only the sensor value. So and this sensor value we wanted to upload to the ThinkSpeak IoT cloud. That is the target. So let me stop the program. So to upload the data, you need API request. So let me jump into the channel. So this is my channel, right? So this is my channel. So which is created in the before this, right? So what we have to do is we have to go for API request. We have to go for API request. So you have to see the first API, because that is the where you can upload the data. That is nothing but write a channel feed. Okay, so let me copy this. So you have to copy this request. So you should not copy from get. Okay, you have to copy from only HTTPS. So we have to copy from HTTPS to last. What is there here? In this we have some API, and we have our write API key and ampersand field 1 equal to 0. So let me copy it. Okay, so copy. So let me come back to Google Colab. So let me create a variable for this. Okay, so let me create a variable, say a equal to, or you can say cloud underscore API equal to, so that there will be no paste. So cloud underscore API equal to, so cloud, I have created a variable called cloud underscore API equal to single quotation open, because this is a string data type, https://api.thinkspeak.com/update !API underscore key equal to your API key followed by ampersand field 1 equal to 0. So what do you mean by this? Ampersand field 1 equal to 0 is nothing but always 0 will be uploaded. So our target is not to upload 0. Our target is to upload the distance value which has been read. Okay, that is why what we have to do is we have to delete the 0. So sometimes people will forget this. So that what will happen? Every time 0 will be uploaded. So if you forget to delete 0, so every time 0 will be uploaded. So instead of sensor value, so 0 will get stored. Instead of plotting sensor value, 0 will get plotted on the graph. So that is why you have to remove this 0. Okay. So this is the API. And to call this API, we have to import some library. To call this API, so we need to import some Python library. So let us import that. Import space URL lib dot request as URL. So there is a one library called URL lib.request. So Python, if you are aware of Python, Python is available in two versions. Okay, one is Python 3, second one is Python 2. So this is the version. The Google Colab, you will have Python 3. On Raspberry Pi, you will have Python 2. Okay, you will have both Python 2 and Python 3, but I am running on Python 2 now. Okay, so this is Python 3. So this library is existed only in Python 3. Okay, if it is in Python 2, I will show you in the next example. Okay, so as of now it is Python 3. So URL lib.request as URL. So this library has to be imported. This is a built-in library with Python. So in order to call the API, so if you want to call the API, this library has to be imported. So yesterday I have explained how this library, what is this libraries and all, right? So now we have imported this. Now here, so after printing t, we have to upload the data. So say a equal to URL open of. So URL open is a method which calls the API, cloud underscore API. But cloud underscore API, if you see, it is ended with equal to symbol. Okay, so that is why what you have to do, you have to plus t. So what is t here? T is nothing but sensor value. Okay, so a equal to URL open of cloud underscore API plus t. So thereby, so the data sensor value will be uploaded to ThinkSpeak. Okay, so let me print the value of A. So let me print the value of A. So here the data will be uploaded to the cloud API. So we are appending plus T here. So plus T is nothing but sensor value. So the sensor value is getting stored in T, right? So I've just appended plus T here. Plus is nothing but appending. So which is nothing but string concatenation. So print of A. So I'm just printing the value of A. So when I run this program, if you see, when you run this program, you can able to see 174.57 and HTTP request response. Okay, so you can able to see HTTP response here. So if you are getting this HTTP response, it indirectly means that the values are uploading to ThinkSpeak. Okay, so uploading data is very simple, right? So in Python that is only one line. So that is why Python is preferable in many applications. So here it is only one line, but when you look at Arduino, so you will have different number of lines. You will have at least 50-60 lines in order to upload the program in Arduino, because in Arduino the programming language is C++. So when you have C++ there, so you will have little bit lengthy program in order to upload the data. But here in Python it is just a single line. So what you have to do, you have to call you have to call the method, and then you have to append the data. So that will store the data in the cloud. So here, so your data is been uploading to the cloud. So let me jump back to the cloud and show you that. So let me click on private view. So when I click on private view, you can able to see some data there. So you can able to see the sensory values here. Okay, that is getting uploaded. So you can able to see the graph also. So here, here what is happening here? Data is being collecting. The data is getting stored, and and the data is getting visualized. Okay, so on the field 1 chart. So like this, all the data will be uploaded. Okay, so you can see the live graph also. So it keeps adding the sensory values when it receives from the Google Colab. So have you understood this? Any doubts? Any doubts so far? Can I go for next? Okay. So here, let me what is this? Let me jump to API keys. And let me show you the read a channel feed. Okay, so read a channel feed. Let me copy this URL from HTTPS to last, read a channel feed. So if you look at this URL, you are having feeds.json, so all the sensory feeds, and at the last you are having ampersand results equal to 2. So when you have ampersand results equal to 2, it can able to retrieve only last 2 results from the database. Okay, so let me copy this and let me open a new tab. Let me paste it there. So this URL will be accessed. So you can able to see here what is the channel ID, what is the name, and what is the description, latitude, longitude. Generally it is 0.0. We have not given anything. Field 1 ultrasonic sensor. Okay, created at so and so time, updated so and so. So that's okay. So let me look at the last entry ID. Okay, so last entry ID is 15. So what are the feeds here? Created at and what is the entry ID 14 and 15. So these are the two fields. Okay, so these are the last two fields which has been uploaded to the database, 14 and 15. So their values are like 175.04 and 175.03. so here our results equal to 2, right? So when you put results equal to 1, so if you want to retrieve last one result, so you can put results equal to 1. So you can able to see only one result. Okay, so which is entry ID 18, because as the program is running continuously, it is uploading the data. The field 1 is 175.01. so when you write results equal to 10, so then you will get last 10 fields. Okay, so you will get last 10 fields. So field 1, so you can able to see the last 10 fields here. Okay, so when you remove this, you can able to get all the data. Okay, so when you remove ampersand results equal to something like that, so you will get all the data which has been uploaded so far. So you can able to see 20 entries, so which has been uploaded to the IoT cloud. So you can able to see that. So when you remove this ampersand results equal to, okay, when you put ampersand results equal to 1, so you can get only one data, which is a last entry data. So this is how you need to do read at action. Okay, so I am not doing programmatically, but I will explain programmatically sometime, maybe tomorrow. Okay, so as the time is running off. So ampersand results equal to 1, so you can able to see the last data. Okay, so let me stop this program. Let me show you how to run the program without Google Colab. So here with IoT gateway we did it, right? So let me show you how to do without IoT gateway. Okay, let me copy this API. So API is very important. Okay, so let me copy this API. Okay, so let me write program in Raspberry Pi. So Raspberry Pi itself will upload the data. Okay, so let me open the program, sudo space nano space slot underscore gateway.py. So let me add some lines. Okay, so here, as I said, I am using Python 2 in Raspberry Pi. So let me import a library, import space URL lib2 as URL. So this is a URL lib2, double L should be there, URL lib2. So URL lib2 is a built-in library to access the API. So on Python 2, so on Python 2 you will have one library, on Python 3 you will have one library. Okay, so let me define a cloud underscore API here. Cloud underscore API equal to single quotation open, we have to paste that API. Okay, let me paste. Okay, single quotation close. So this is the API. So here if you see the API is ended with equal to symbol. Okay, so there is no 0 here. If you put 0, 0 will be uploaded. Okay, so now let me upload the data. Okay, so let me upload the data. So instead of sending it to collab, so let me put comment for it. Okay, so I wanted to upload the data. Say URL dot, here also you have to call the same method, URL dot URL open up cloud underscore API plus distance. So here no need to do splitting and all. Okay, you need to do splitting only on collab. So here we have a variable called distance. So that distance we can directly append it. But here what is the data type of distance? So here when you look at data type of cloud underscore API, so data type of cloud underscore API is nothing but string data type, whereas distance is a floating point data type. So that is why what we have to do is we have to do typecasting here. So instead of writing distance, we have to write str of distance, because cloud underscore API is string data type. So let me store the response in some variable. Okay, so let me have a equal to, and let us print the value of a here. Okay, so these two lines, when you have these two lines here, the Raspberry Pi itself can upload the data. So let me run the program. So Control X, Y enter, and sudo space Python space, so let me clear, sudo space Python space slot underscore gateway.py. So let me enter this. So it will read the distance and it will upload. So you can see the HTTP response here, add info URL. So which means that the data is been uploaded. Okay, you can able to see the data on cloud directly. So no need to say it on Google Colab, because without Google Colab we have uploaded the data. Okay, now you can able to see. Now you can able to see the data is printing up. So 12:30. Now the time is 12:30. So you can able to see. So when you move your mouse to the dot symbol, you can able to see the ultrasonic sensor value and when it is uploaded. So you can what is the time, at what time it is uploaded. You can able to see all the details there. So like this, you have to upload the data directly onto the IoT cloud without any collab. Okay, so without any collab, you can easily upload the data. Okay, so all the sensor values can be easily uploaded. So when if you have two sensors, you have to create two fields. Okay, I'll show you before I wind up. Let me show you a simple syntax. When you have two fields, what you have to do. Okay, when you have two fields, then a little programming will be changed. Okay, in the programming, what you have to do is, so I'll write a simple line. Okay, so if you have two sensor values, what you have to do is, let me put in comment, because as of now I'm not having that. A equal to url.url open. So let us say T1 is sensor 1 value and T2 is sensor 2 value. Okay, so let us say we have two sensors. If you know how to handle two sensors, you can handle 8 sensors also. Okay, A equal to url.url open of cloud underscore API plus T1 plus single quotation open, single quotation close, ampersand field 2 equal to. So this is what you have to do. So you have to append ampersand field 2 equal to, because when you are doing IoT prototypes or IoT projects, so you will have more number of sensors, right? So when you have more number of sensors, you have to append. So ampersand field 2 equal to plus T2. So when you have one more sensor, then what you do? Plus single quotation open, ampersand field 3 equal to plus T3. So that is what you have to write. So you have to increase the appending here. So you have to append them into a one string. So cloud underscore API plus T1. So no need to write ampersand field 1 equal to, because it is already there in the cloud underscore API. So but there is no field 2 equal to. That is what we have to do. After adding T1, after appending T1, so you have to write ampersand field 2 equal to. So that is a value, right? That should be in single quotation. Plus variable name. So what is the variable name here? T2. Plus when you have one more sensor, single quotation ampersand field 3 equal to, single quotation close, plus T3. So like this, so on. You have to keep appending the sensor name, the field name and the sensor value. Okay. So hope you have understood how to append more number of sensors. So this is only one change which is required when you have sensor value. So the same line you can write it on Raspberry Pi also. So it will upload the multiple sensor values. Okay. So any doubts? So we have seen how to upload the data onto the ThinkSpeak IoT cloud, right? So afternoon I will show you the quick MATLAB analysis, how to do MATLAB analysis on this, and then we'll slowly jump into the AWS IoT core in the afternoon session. So any doubts so far? So thanks for joining me in this morning session. If you have any queries, you can feel free to ask me, or you can call me on the mobile number which is given to this YouTube live, or you can also mail us on mad@madblocks.tech. So thanks for joining me. So we'll meet you back at 2:30 in the afternoon session. Is it fine?